And example 10. All right, so, well, let's see what we can do. Example 10. So, the derivative of sine x is, let me go ahead and go back to blue. The derivative of sine x is the cosine of x. The derivative of cosine y equals, well, it's negative, so plus a negative sine y, y prime. The derivative of sine 2x is cosine 2x times the derivative of 2, which is 2. So it's 2 times the cosine of 2x. Okay, so let's solve. So minus sine y, y prime is equal to 2 cosine 2x minus cosine x. Therefore, we get y prime is equal to 2 cosine 2x minus cosine x all over minus sine of y. I'm going to go ahead and take this negative sign, bring it up top, flip these two, and I'm going to write this as the cosine of x minus 2 cosine of 2x all over sine y. I hope that made sense. A negative sign actually can go top or bottom. It doesn't really matter. So I went ahead and brought it up here. And when I distribute it over this, the negative this and this one becomes positive. I put it first. This one is negative. I put it second. That's all I've done. So there we go. So we have y prime. Now, y double prime. Okay. So y double prime. Let me do this one in red. So y double prime, I'm actually going to be differentiating this one implicitly. Okay, so it's going to be this times the derivative of that minus that times the derivative of this over this squared. So that equals sine y. This times the derivative of this. The derivative of cosine x is minus sine x. The derivative of this cosine 2x is going to be minus 2 sine 2x. Minus 2 times 2 is 4. It's going to be plus, so it's going to be plus 4 times the sine of 2x. That's this times the derivative of that. Minus this cosine x minus 2 cosine 2x times the derivative of this, which is cosine y, y prime, all over sine squared y. Okay, so let's take a look at this before we do anything. So it involves sine x, it involves sine y, or cosine x and cosine y. It looks like the only y prime term that we have is here. That's this one. So if you were going to simplify it, you don't have to. If you actually have to, for y prime, well, this is y prime. So you take this expression, you put it into here, and then you simplify the expression as much as possible. I'm not going to go ahead and do this. For this particular problem, something that's going to end up looking like this, I would just leave it alone. I would just, unless you, if your teacher is going to have you do this, where you actually have to substitute in and only express things in terms of x and y, they're going to have to give you something simple. Otherwise, you'll be here for 4 days doing this. But for something like this, you are going to deal with it at some point in your career. You have y prime, you have y double prime. If you need to, you go ahead and put it in. And again, most of the time, when you're working, you're going to be working with mathematical software, so it's going to be doing this for you. So that's it. Straight differentiation. You differentiate the first one implicitly, you get this, you differentiate the second one implicitly. It is going to get progressively more complicated simply by virtue of the fact that this one happens to be a quotient rule. Well, I hope that made sense. Thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.